Today we're going to learn about P-type semiconductors for grade 12 physics. Semiconductors are materials that have electrical conductivity between conductors and insulators. They are the foundation of modern electronics. Before we discuss P-type semiconductors, let's briefly review pure or intrinsic semiconductors. Silicon is a common semiconductor material with 4 valence electrons. In a silicon crystal lattice, each silicon atom forms covalent bonds with 4 neighboring silicon atoms. Here's a 2-dimensional representation of a silicon crystal lattice. Now, let's see what happens when we create a P-type semiconductor. P-type semiconductors are created through a process called doping, where we add impurity atoms to the silicon crystal. For P-type semiconductors, we add trivalent impurity atoms like boron, which have only 3 valence electrons instead of 4. When a boron atom replaces a silicon atom in the lattice, there's a missing electron, which creates what we call a hole. In P-type semiconductors, these holes act as positive charge carriers. When an electron from a neighboring covalent bond moves to fill the hole, it creates a new hole at its original position. This process allows current to flow through the semiconductor. In P-type semiconductors, holes are the majority carriers, while electrons are minority carriers. Now, let's discuss the benefits and applications of P-type semiconductors. First, P-type semiconductors can be combined with N-type semiconductors to create PN junctions, which are the foundation of many electronic devices. These include diodes, which allow current to flow in only one direction, transistors, which amplify and switch electronic signals, and solar cells, which convert light energy into electrical energy. P-type semiconductors have several additional advantages. They provide precise control over electrical properties through doping concentration, have good temperature stability compared to intrinsic semiconductors, and enable high-density integration in modern microelectronics. To summarize, P-type semiconductors are created by doping silicon with trivalent impurities, creating positively charged holes as majority carriers. They're essential components in diodes, transistors, solar cells, and virtually all modern electronic devices.